appreciate it. Antonio Ibarra, I see in there. We got Thomas, Steve Simpson from TO. Good morning, everybody. We are so happy to have you here on this beautiful Thursday morning. Please let us know where you're joining us from on this Thursday morning. I am coming to you from beautiful downtown San Francisco in the fragrant Soma neighborhood. And our guests this week, Paula, where are you joining us from, Paula?
Hey, hello, how are you? Thank you, Phil, for having me here. I'm so
Hmm.
excited to have this conversation with you.
Same, same. Where are you joining us from? What part of the country are you in, Paula? Or the world, that is.
I'm North Carolina,
Right
Raleigh.
on. North Kakalaki. My dad's family is all from North Carolina. Beautiful part of America.
Beautiful
Um,
part, a lot of pollen these days.
I bet. Oh yeah, no, it's yeah. I visited in the summer and spring, and that is the truth. Samet, where are you joining us from?
Hey everyone, I'm joining from Durham, UK.
Right on. It is an international program today and every day. People out there watching as you join on YouTube, Twitch, Twitter, Facebook, Zoom, etc. Please type into the chat where you're joining us from. I see we've got Madrid, Spain here. Steve is joining us from Smart Mansion Incorporated in Toronto. We've got a few more folks chiming in over. Let's take a look at our other platforms here. We've got Morocco over on LinkedIn. Dr.
Cool.
Atul Kumar from India.
Could we
Howdy
say
ho.
hola?
Hola. Yes. Buenos dias. Hello, Kazakhstan, Calgary, Alberta, Canada, Saline, Michigan, a town in Michigan I have never been to, despite being from there. Sinaloa, Mexico, Argentina. Mayor says, hello, Phil. How are you doing, mate? Greetings from London. Greetings. Greetings. I'm doing great. Hello, Pakistan. Hello, Finland. Hello, Slovenia, Austria, Rakita, Tunisia, Dublin, Ireland. We love to see the global OpenCV community. More UK from Basingstoke. One of the great names, I think. England has a special power for giving things just delightful names, I feel. I think Basingstoke is one of those. Just no other country is going to have a Basingstoke. Like, come on, come on. Hello, Sacramento, just a stone's throw away here. Toronto, Vietnam, Gay Paris, the fictional city of Chicago, Colombia. Hello,
Wow.
Namaste, Nepal, Egypt, or as a friend of mine's dad pronounced it when they read it for the first time as a child, Egypt. Hello from sunny London. That's got to be a rarity. Hello, Latvia. Hello, Chennai. This is going to be a fun one, folks. And here come the AI assistants. Every single episode, about 3 minutes into the show, we are bombarded. There's more and more every single time. This time we have 1, 2, 3, 4, 5, 6, 7 AI assistants in this chat. Eventually, it'll just be them talking to each other, I think, instead of the audience. Yes, thank you for your assistance, AI assistants, but I don't think we need 8 of them. Okay. Hello again, India, Latvia, more Nepal. I didn't realize we were so big in Nepal. I'm going to have to visit now. Yeah, so I think, I think we can probably get started here. Let me do my little intro. Hello. Ooh, that was a bad one. Let's try again. Hello out there, everyone. Good morning out there, and welcome to OpenCV Live. It's Thursday at 9 a.m., which is when we do this show. I am Phil Nelson, your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. It's Mr. Nelson. If you're nasty, but you, my dear friends, can call me Phil. And on today's episode, I am flying solo with the hosting duties. Dr. Satya Malik is on assignment, so I will do my very best to be 2 people today and run the show and also host it. Thankfully, we have some awesome guests for you who are going to do most of the work and make this a very exciting and interesting episode. Joining us today are Paula Ramos. Paula.
Thank you, Phil. You are my friend. I can call you Phil, no?
Absolutely,
So
absolutely.
I'm Paula Ramos. I'm working at Intel. I am AI evangelist at Intel. So
Excellent.
working in computer vision for the last 20 years.
Sweet. And also joining us, Samet.
Hey everyone, I'm Samet, joining it from Durham, UK, basically AI research engineer and scientist, Intel. Yeah, doing this machine learning stuff for, I think now it's more than 10 years now.
Wow. Yeah, that's great. We've got a very experienced crew here today. I myself have just about probably what's like 12 years, I think I've been doing computer vision and AI stuff. So, gosh, how time flies when you are just being constantly amazed and surprised by the weird stuff computers can do. So before we get started today, we're going to have a really interesting presentation and an exciting announcement about the plans for OpenVINO and CVPR. Earlier this week, they just announced something on Hackster.io, a big competition. We'll be talking about that. Super excited for that. But before we get started, I'm going to share my screen here and remind all of you good people out there of the many ways that you can support and help OpenCV. OpenCV, the Open Computer Vision Library, is a nonprofit, and also our software is released under a very permissive open source library, as I think most people here probably know. I'd just like to do a quick shout out and thank you to all of the OpenCV member and partner organizations who give us support either financially or by helping with developer time and things like that. You may notice a few new ones on here, and we'll have a couple press releases about those pretty soon. Specifically, you might see ARM on there. We recently just had a pretty big release of some much improved performance and compatibility with OpenCV on ARM devices, thanks to ARM. We really do appreciate them. But hey, maybe you're an individual and you don't have $6,000, $30,000, or $100,000 to help OpenCV with. Maybe you've got like $40. In that case, you can buy an OpenCV t-shirt, a dog bandana, a pin, or a bag. These are all available at opencv.myspreadshop.com. 100% of the proceeds and profits from this go to the OpenCV library, making that great and making it so we can keep doing these fun shows and going to events like CVPR and Embedded Vision Summit every year to do community with y'all and have a good time. We've got 3 flavors of the I Love OpenCV shirt in English, simplified Chinese, and in Espanol. So go check those out. I did see one of you has now purchased the pet bandana and sent me a photo. I will be sharing that photo later in the episode. You have to stay tuned for it. But I'm still disappointed in every other one of you that has not purchased the dog bandana and sent me pictures of your dog in it. Get on that right now. Though you might want to wait for a sale. They have sales pretty often. There's other ways you can support OpenCV. You can also just kick us a couple bucks via Stripe or PayPal on opencv.org/support, which lists all of the ways you can help out. If you're an organization and you want to become a member org, you can join our member organization plan for bronze, gold, and silver membership levels for a month or a yearly fee that will get you some interesting and cool perks that will help also elevate your brand in the eyes of the global and amazing OpenCV community. You can also sponsor us on GitHub. If you go to github.com/sponsor/OpenCV, you can join one of the 9 amazing human beings who are supporting OpenCV monthly there for $9 a month. I'm going to give them their 15 seconds of fame here by just mousing over their names real quick. Thanks so much, everybody. We really do appreciate your help here on GitHub. Let's see if we can get that number a little bit higher. You can also come, volunteer to be an OpenCV volunteer. If you've got extra time in your week for a couple hours, maybe you can help us spread the word about news and events around OpenCV. Maybe you can even help write some code or merge some pull requests or what have you. All this information is available on opencv.org/support. Also, big news, OpenCV will be at Embedded Vision Summit May 21st through 23rd in Santa Clara, California, just a stone's throw from my Wizard Tower here in San Francisco. We will have a little 5x10 booth there as well and some stickers and buttons for free, so go check out Embedded Vision Summit. I will share a sign-up link for you there, which you should be able to get a few dollars off the registration if you're planning to attend. So stay tuned for that later in the episode. Also, the OpenCV newsletter will have your sign-up link. The deadline for that will be next Friday. So check your inboxes for that. Speaking of conferences, OpenCV will also be going to CVPR in Seattle, Washington this year, June 17th through the 21st. The 17th is my mom's birthday. No, the 19th is my mom's birthday. Happy birthday, Mom. OpenCV will also have a booth there. We'll have a bigger 10 by 20 booth this year. So come see me and probably Gary Bradsky, Satya Malik, a few other OpenCV luminaries will be there with fresh swag and merchandise. I know a lot of you last year really enjoyed the red carpenter pencils we did. This year we're going to try to do green carpenter pencils, so stay tuned for that. You can follow OpenCV on LinkedIn. There's us right now. Look at that. Ain't that something? Just linkedin.com/company/OpenCV. Follow us over there. You can find us on Blue Sky, bsky.app, opencv.bsky.social. We're also on mastodon.social @OpenCV. So go check us out there. I think that's all I've got for today. As a quick reminder for those of you who have not joined us recently or have never joined us, one of the things we do on this show is a special giveaway to you in the audience. Stay tuned, and later in the episode, about the 45-minute mark or so, I will ask a trivia question based on the presentation from our illustrious guests, and the first person to answer that question correctly will win the OpenCV course of their choosing. You can go to opencv.org/university to see what courses are on offer. And hey, even if you don't win, maybe pick up a course package, invest in yourself, upskill, get paid more at your current job, or get a better, newer job. We're also taking questions from you in the audience. Use the Zoom Q&A button to ask your question at the bottom of the screen there, or type your question into the chat system wherever you're watching. YouTube, Twitch, Twitter, Facebook, etc., 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 especially all of you folks there on LinkedIn. Let's do a quick numbers check here. We've got about 100 folks watching us here on Zoom, and over on LinkedIn, let's find out. 142 of you over on LinkedIn, so that puts us at almost 250 live right now. So thanks so much, everybody. We really do appreciate you giving us your time every Thursday morning. And with that, I'm going to turn it over to our illustrious guests, Paula and Samet. Paula, take it away.
Thank you, Phil. We are so excited to stay here with you. I think it's my third time here. So, and I always enjoy the conversation with you. You know, it's amazing. It's the second time with Samet.
That's right.
Yeah.
That's right. You're a dynamic duo. I think you now hold the record for having most appearances together on the show. And Paula, I think you're in like third place for most appearances. Current title holder is Joseph Nelson.
Okay, I had the second place. Thank you. I want to have the first one. Okay.
Hey, we got time.
Let's do it. Okay, no, thank you all that you are looking for us, maybe for the previous announcement that we made early this week in LinkedIn, in social media, that we will have presence in CVPR this year as well. So we were there for the CVPR 2022 and also CVPR 2023. But let me, introduce a little bit myself. So, I'm located in North Carolina in the US, but I am originally from Colombia.
That is a delightful photograph, very professional.
So professional. So, and I'm happy to hear that people from Colombia, Mexico, Spain, Latin people is also here listening this podcast or watching us also. That is great.
See?
So, and also we have, my background basically, for the ones that don't know me, so I have been working in agriculture for 17 years, 14 years. And then I moved to the US and start my journey in the US in AI as well. But all the time I am working on AI. So from the very beginning, when we were talking about fuzzy logic, until we were jumping to machine learning, and then we talk about deep learning, and all related with computer vision. So I'm happy to stay here with Samet. So Samet, over to you.
Can we remove my name? It's not my picture. It's not professional compared to you. But...
It's hard to, I mean, she set the standards really high. It was kind of unfair.
Yeah, the bar is too high
I'm
now.
so sorry.
You
Yeah.
got to stop being so photogenic.
Next time we need to work on that, Sam.
Yeah. All right. For those who don't know me, yeah, I'm Samet, based in the Durham, UK. Finished my PhD here in Durham University in computer vision at computer science department. Previously, I was in the States. I did my master's at Penn State, electrical engineering. Yeah, I've been working on this machine learning, deep learning stuff for about like 10 years or so. And more recently, yeah, I'm spending more time on anomaly detection, unsupervised, few shot, zero shot, and all different types of learning. And yeah, spending quite some time on Anomalib. That's what some people know me about. But that's
Awesome.
about it from my side, I guess, for now.
Thank you, Samet. That's awesome. No, yes, we have been working in the computer vision field for a while, and I think that we understand pretty well where the gaps are. So, and we want to show today, a little bit, a little overview about what is going on at CVPR with OpenVINO. But I would like to show you, a really good thing that happened in the past at CVPR. 2022, 2023, we have great years there and great moments. So Phil, you are there. Your face is there.
It's me. It's me, everybody. Look for the guy in the orchid speed suit.
That
So
was
we
really original when I saw that, like there. It was like,
I don't talk about it much in the show, but I actually met my current girlfriend, wearing that speed suit.
I was asking you where you buy that because I really
Yes.
want that one.
I need to, yeah, no, shout out to Wild Fang. Wild Fang is the name of that brand. Super comfortable speed suits. I would love for this show to be sponsored by them. Please hit me up, Wild Fang.
Okay, so we have been there as keynote speakers. We have participated in the demo,
That
demo
event
booth.
too was so much fun at CVPR last year, and huge shout out to Wei and we had such awesome help there. Like I feel like I didn't have to lift a finger.
That was amazing.
Thanks.
So you were
Yeah.
there with one demo, a stable diffusion demo, if I'm not wrong.
Yeah.
But we have a great engagement with this, different third parties. You were there, OpenCV was there, Voxel 51, and also we have multiple demos around Intel, across Intel, not just OpenVINO. And this is really good because we are open the conversation to others in the community. The most important thing here is developers. And we need to show how they can close the gap in between the technology that we can support in the community and the solutions or also the problems. So this is exciting. So we are expecting to have this amazing engagement again this year. And let's see what we have for you this year as well. So we have an amazing participation this year with the multiple things. So we will have a participation in a Bank 2.0 challenge at CVPR, and we will have also a tutorial, full day tutorial on the 18th. So the challenge is a challenge that is is a workshop challenge. And also we will have a tutorial. So the challenge, the workshop is the 17th and the tutorial is the 18th. And we will have also the networking event and more demos around, CVPR. So I want to pass this over to Samet so he can explain us what this challenge about, what kind of things we want to achieve, and a little bit more about the overview of the workshop as well, as he will also be a keynote speaker in the workshop.
Hooray.
yeah. So the VANDA Visual Anomaly Detection Workshop is one of the workshops organized at CVPR. So there's like many of them. But for those who are specifically interested in visual anomaly detection, this is the place to go during the event. And similar to last year, which was the first one, this year there's going to be a challenge. So this challenge is usually based on some of the problems, the real world problems that we are facing in industry. Right. So this year we're gonna have two tracks or two categories, and we both of these categories are kind of some of the challenges we are facing in the real
So,
world applications.
Samet, before you continue with the description of the challenge and tracks, could you give us a little bit, I mean, an overview about the workshop itself? So what kind of things we can see there, you know, what kind of, I mean, maybe some highlights from the past challenge, I mean, sorry, the workshop, that would be really good to understand. What is the dynamic that, you know, participants will have in the workshop? What kind of new things we can see there? And let us know a little bit of the organizers as well.
Yep, sure. There's like it's, as I said, it's a visual anomaly detection workshop, so specifically focusing on visual anomaly detection, novelty detection, and similar areas. So anything that is related to unsupervised learning, semi-self-supervised learning, or novelty detection, yeah, that could be a potential paper or a poster published at a conference. So last year it was the first one of this workshop. It was a half-day workshop, but there was a great interest and a great audience. So this year the organizers decided to extend it, and then it's going to be a full-day workshop this year. And we expect to have probably the organizers have the numbers now as the papers are accepted already. But yeah, I expect that there's going to be so many more papers this year, so many more engagement and so on.
So a little note, Samet, I don't know if people here that is watching this video right now, this live, you can scan this QR code and go directly to the web page that the workshop has. That will be really good. You will have more information about that, you know, the dates, the registration, and so. But right now, this is closed for papers, no? No, there are no accepted papers anymore.
No, the deadline, the paper submission deadline was passed, and the papers have already been accepted. So, as I said, the organizers probably know the numbers, statistics, but yeah, there's going to be probably much more compared to last year. But even last year, they were like, even though it was a half day event, yeah, there were quite cool papers there.
Awesome. So I think that, I mean, maybe there are some people in the audience that they are familiar with anomaly detection, but if we need to explain what anomaly detection means, I think that would be really great. So we have some videos prepared, and, you know, maybe to show you the anomaly detection fundamentals. What is that? You know, what is the meaning of anomaly detection? So basically what we have here is a real world data sets. You know, we have imbalance. So it is difficult to find balance on those data. So we have a lot of good information and not enough defects to create, you know, a model, to train a model. And this is just an example. But in some cases, we could know about the abnormality that is showing there, or maybe we don't know. And this is, you know, in the most cases, we don't know what the abnormality means. It's something that is out of the distribution of the data. So basically, that's the point. So Phil, do you have any questions about this general concept about anomaly detection?
I'm pretty familiar. I know the audience is probably as well, but a quick shout out to someone in the chat who correctly identified the model number and function of this board. It's a echolocation sensor, right? I believe that's what this board does. So shout out. Yeah, like maybe talk a little bit about like. So one of the things I find interesting is deciding what anomalies to pay attention to. Can you talk a little bit about that? Because some of them are not really important, right? Like you don't necessarily care if one of the header pins is kind of bent here. It's still going to work fine. But there are other issues, like say on these surface mount components, where if there's an anomaly, it will materially affect how the thing works, right?
Yeah, it depends on what customer wants when during this quality assurance stage. Well, sometimes they just say that's fine. This half pin, it will work. But sometimes they're quite picky, and then they say, okay, anything that's kind of even with a slight deviation, yeah, we don't want it, and we need to pick it up as an anomaly. So the requirements might change depending on the customer. But yeah, so what they usually do is that, here's the normal one, and find me anything that doesn't look like this or anything like slightly deviate from this. So basically, that's what we usually focus on.
So I have a question, Samet, because you are an expert in anomaly detection. So in the past, maybe you have a lot of challenges. I know that you create a library, Anomaly. So what was your inspiration to create that library? Because maybe you were facing some challenges. So could you let us know more about that experience creating that library?
Yeah. I think I briefly explained this story in the previous episode as well, but for those who are not familiar with it, maybe I can just reiterate it. So
Yeah,
when I was
please do.
when I was doing my PhD, I was mainly initially working on a supervised solutions like, object detection and classification and so on, like localizing the objects. And then we found a work like a solution that works fine, like 90+% accuracy. And then when we went to the customer, and the customer was happy, but that they were saying that, okay, this model picks up these defects or anomalies. Okay, but what happens like when I have this and that defect in the future, or maybe anything that I don't know now could be a defect or anomaly in the future. So what happens next? So like initially we thought that, okay, we can retrain the model and fine tune the model, including that class in our data set. But we quickly realized that this solution is not like scalable and maintainable in the long run, because the new classes will keep coming. So at that point we decided that, okay, we need to focus on what we have, like the normal ones, because we don't know what the abnormalities is and how it will change in the future. So that's how we started to focus on this anomaly detection problem, like unsupervised anomaly detection problem, where we only focus on the normal samples during training so that we can find the abnormalities by comparing them with the normal ones. And then this is how it started. And then when we joined Intel, we released a library called Anomalib that has like all these state-of-the-art anomaly detection models and also a bunch of cool features.
Yes, I think that for the attendees on this live, so you need to Google Anomalib with B at the end.
We'll drop the link in the chat for all you good folks out there.
Perfect. Thank you, Phil. And I think that this is a great story. I think it's inspirational for, developers that are trying to, close gaps or move the knowledge. And I think that we have a great opportunity with this challenge. The challenge that we have with BAN 2.0 is because we are also looking for the opportunity to improve the state of the art that we have for the anomaly detection. And so basically this year we have 2 tracks. And as Samet was mentioned at the very beginning, so we have two categories. And I would like that, he can explain us a little bit more about every track that we have. But basically, long story short is we have 2 categories. One could be considered for beginners, and then will be considered for experienced developers. Basically, in the first track, we want to create robust anomaly detection for real-world applications. And the second track will be a little bit more complex because we want to find a few-shot learning for logical and structural detection. And we will explain you that in a moment.
One quick question before you get started there that somebody already asked here on LinkedIn. Who is the challenge open to?
Anyone?
Just does it matter where they are in the world? Do they have to be like a student, for example, or is it U.S. only? Any restrictions like this?
It's worldwide. We have some rules so they can visit the hacks there. IO page. I don't know, Phil, if maybe you can share the link with them.
Yes, we will.
We have some rules. It's worldwide. Students, developers, junior developers, experienced developers. We want more people to participate on this. If you have experience on computer vision, it's great. But if you have experience also maybe in statistics and you find a solution that could help us to solve the category 1 or category 2, it's also something that is open. So we have no restrictions.
Yeah, I mean,
Excellent.
that's the beauty of this, interdisciplinary style, right? So like we call this challenge, but for someone from another discipline, they might already have some solution to this and then say, hey, we already have something to this, and then we can just fix or we can address this problem. So yeah, that's
you never know. You never know.
Yeah.
So another thing, Samet and Phil, is that this challenge is in the context of CVPR. But if you don't want to go to CVPR, also you can participate on the challenge as well. So it's worldwide for all people and developers that want to challenge themselves with this idea.
Excellent. Yeah, and folks, you can go to hackster.io/contest, and you'll see that right at the top of the page there.
That was launched on last Monday, and we have right now around 100 participants. 0 submissions, but 3 days is too soon to see some submissions there.
Submissions are due in 44 days. So you got plenty of time.
That's right. So let's continue with this explanation. So, and I remember last time I challenged you, Phil, to identify the defect here. So could you let us know where the defect is? I think that is a simple task.
This one's tough, but I think it's the ones that have clearly burned out.
That's right.
Those are scorch marks. Yeah.
That's right. But when we increase the number, it's a little bit difficult to identify where the defects are.
That's true.
But right now we have all of images are so similar. We have same lighting conditions. We have maybe the same camera. We don't have blurry images. But what happens if for some reasons lighting conditions are changing or the color temperature of the image is changing? And that is the reason why we want to create more robust anomaly detection algorithms for the real world scenarios, because in the real world scenarios, we can see these kind of things. So this is the reality. I think that's similar that Samet you were facing at the very beginning of your journey with anomaly detection.
Yeah.
This is still a problem.
Can I chime in here? Because you had some problems last year at CVPR, Paula, with your cool demo. If Phil, you remember Paula's robotic arm demo? Yeah. So for those who don't know, maybe you can check out Paula's LinkedIn account, because I remember that she posted that cool video. So she quickly trained an anomaly detection model within a couple of minutes, 2-3 minutes, that picks up some defective cubes with a robot arm and then puts it aside on the on the band. So she did the same demo at CVPR as well. She was, it was, stressful process because a live demo, technical problems always happens.
It's always stressful when it's live every time. That's why this show is live every week. I'm microdosing the live demo stress.
Yeah, exactly.
No stress with this show, but CVPR is the top.
Yeah, no, it's big deal.
When she was training the models, after a couple of minutes, okay, the robot arm is working, everything is fine. And I was like, Paula, maybe we should just move this background to the side, or maybe we can tidy up this place. And she was like, no, don't touch it, because lighting condition will change and everything will mess up, right? It's like everything was or maybe she trained the model in the morning, but afternoon, the lighting condition changes within the exhibition hall, and then everything will just mess up again. So she needs to train a model again, right? So that's what happened at CVPR last year. So all these conditions do affect the performance of the models. And in a real world setting, in a factory floor, that always happens, right? So the camera angle, lighting conditions, noise levels, you know, all that sort of stuff. So even though we have some cool high performing model for training, when we deploy it, yeah, there will be some problems. So this is what the challenge is about.
So I think that, this is I will say common question, how we can fix this, how we can maybe create a robust algorithm for support that variability and the distribution, because the distribution will be huge. So maybe we need to take a lot of information. We need to take multiple conditions with multiple cameras. But this is a paradigm that we need to see. And this is the idea of this track number 1. So Samet, could you explain us a little bit more about what kind of models we are expecting to see here?
I mean, it could be any sort of model. You know, there could be some ensemble models that participants can try, or, you know, maybe they can train multiple models on different types of data, transforms and augmentations, or they can try a single model with multiple data transforms or maybe perturbations on top of the existing data sets. They can have some sort of validation time augmentations or test time augmentations after training the model. So it is completely up to the participants. We don't want to limit, you know, their imagination. Like they can come up with any sort of solution they want. So that's why we didn't want to limit the submission guidelines with such criterion.
So, and for the next one, I want to explain the next category. But I really want to see if maybe people have some questions about the category number 1, the track number 1, that maybe we can answer. But moving forward, I want to challenge Phil again.
All
this
right.
this is the normal package of screws and nodes there. You know, this is normal. This is something that we are expecting to see. And now when we see that maybe we have 2 nuts, 2 washers, and we have a short screw and a long screw. Now, we can see that maybe we have something like that. So it is possible to say that something is abnormal in those images?
See, there you've got 2 long screws on the one on the left and no short screw.
Oh.
You win.
These are, I think, the same bolts that my 3D printer uses, so I'm pretty familiar with them.
So yes, this.
Right.
Go ahead, Samet.
There was one on the right as well.
Didn't even notice that.
This one is broken. Okay, and maybe here the challenge is a little bit more difficult because we need to understand the structure of the data. So, and I will pass this over to Samet for explaining in depth the category number 2.
Yeah. For those who are familiar with last year's challenge, it was about again some sort of zero and few shot learning, but it was based on the Visa dataset that Paula showed a couple of samples at the beginning of this slide deck, right? So the chips that you guys were also talking about. So the last year's challenge were based on, as I said, a zero and few shot learning approach on the Visa dataset, and the Visa dataset is only focusing on the structural defects, right? So the bends and scratches, or maybe some cracks and that sort of defects that are, we call it structural. In this year's challenge, we want to focus on logical defects as well, in addition to the structural. So the Paula just mentioned the logical defects in the previous slide, right? So it could be maybe a missing component, or maybe the ratio of the material might be like, maybe let's say on a normal image it should be like 50-50, but in an abnormal case it could be like 20 to 80 and that sort of stuff. Or maybe like there might be a 2 long screw needed, but there's like a 1 short and one long. or maybe like you have in a factory floor where you have like apple juices, but you just label them as an orange juice, you know, that sort of stuff. So these are kind of logical defects, right? And in this challenge, we are interested in few-shot learning. And what does few-shot learning? Maybe I can just briefly mention that. So rather than training a model on like a whole chunk of data, like tens of hundreds or maybe thousands of images, instead we just train the model on one image or maybe two images. And then with few-shot in this challenge, we allow participants to use from 1 to 8 images. So 1, 2, 4, and 8 images. And then we're going to average the scores for each K shot, basically. So that's the challenge, and why we call it VLM, because in last year, so the challenge was based on a baseline paper, which was called WinClip. It was a clip-based, a zero-shot, few-shot paper. And then there were like some solutions that won the challenge. They call it, I think one of them was called segment any anomaly, which is kind of similar to you know, the SAM models that are out there, like quite popular nowadays. So basically these like large vision models, or maybe some large models that also integrate text or language as well. Because in the last year challenge, we saw that a lot of participants utilize these language models, not just, you know, use these images, but also they provided some prompts as well, saying that, you know, there should be 2 nuts, you know, 2 washers, and one short and then 1 long screw in this. So, you know, that prompt is kind of useful to the overall pipeline. So this is kind of similar to the last year's challenge. But as I said, the only difference is we also are interested in the logical defects in addition to the structural defects. Hope that makes sense. If not, like ask your questions in the chat. I'm happy to answer.
That makes sense to me. I don't know if because I'm familiar with the challenge. It's super clear.
Right.
So the second thing that I think that is important, because we talk about, you know, challenge, the models, but also we need to talk about which data sets we want to utilize here for the challenge.
Mm-hmm. Yeah, I mean, the NVTech team kindly agreed that we could use their data set for this research purposes, you know, or the benchmarking purposes. Yeah, so thanks to them. So for the first track, we need to use NVTech AD. So it has 15 categories, all structural defects. And the second one, we're going to be using NVTech Loco. Logical something, I don't know, I need to double check, but it's something related to like a logical anomaly detection. So it has both structural and logical defects. For example, maybe if you can see in the image on the right, so there's breakfast box, screw back, push pins, splicing connectors, and juice bottles. Maybe we can have a look at the breakfast box, because we quickly looked at the screw bag in the previous slide. So the breakfast box in the anomaly-free one, the top one on the left. So we see that there, like, you know, on the left, there are certain fruits. On the right, there's like some sort of a proportion, like the oats and the other nuts. But when we look at the structural anomaly, you know, there's something wrong with is it the apple or orange? I can't see, it's a bit small to me, but yeah, there's something wrong on the fruit, right? So that's kind of a structural defect. But for the logical anomaly, I don't know, can you tell the difference for the logical anomaly? There's something wrong on the right-hand side of the box.
Yeah, it seems like they're encroaching on each other's space. Basically, the positioning is slightly incorrect on what are those, like banana chips or something?
Yeah, the banana chips, I think, yeah. And yeah, also it might also be like, you know, the proportion may not be the same as well. Like, you know, in the first one, there's like a fewer banana chips maybe, But in the logical anomaly one, it's a bit like passing the first half, I guess. But yeah, hopefully you get the idea. So that's called like some sort of logical anomaly compared to the anomaly-free one.
So right now we have two challenges. We are expecting to have different models, and we will use different data sets per category, per track. And that is that is really good. I think that we have clarity, but I think that it's important to understand that we are also using a submission platform that is Hackster. So as you know, Phil was mentioning at the beginning, you can scan this QR code and access the challenge phase that we have in Hackster. So right now I think that we have more than 100 participants, and we have discussion channel there. We have, the rules, the overview. You can see all the the overview, basically the same description that we are making today. And also for sure the submission. We want to evaluate the submissions and also keep you posted on the leaderboard that we will have, and we will post this in Hackster as well. So
That's right.
basically,
Hackster,
ahead.
the official community platform of OpenCV and an OpenCV Silver member. Shout out to Hackster.
Yes, Hackster also happy to have this webinar. Like, hey, yes, we are partners with OpenCV.
That's right. Yes.
Nice.
Hello, Ginger. If you're watching, hello,
Jessica.
Alex and Jessica. Yeah.
Hello and thank you, because they are making an amazing job with the landing page of the challenge. So this is really
Yeah,
good.
it looks great.
So I want to ask Samet about the leaderboard because we have two categories, but basically we will have F1 Max in both, and we want to keep all people and teams posted on what is the the rank that they have basically.
Mm-hmm. Yeah. So for the first category, we're going to be evaluating image 1 and pixel F1 scores. And we're going to be evaluating the performance on a data set that we are going to create on our side. But during the submission process or the contest process, we're not going to share this test set because it's, for a fair comparison. And then we're going to have like 3 different test sets. So just to avoid some lucky shots, so we're going to average them. But for image F1, we're going to be evaluating the image level score. So like, given an anomalous image, if the model predicts that there is an anomaly inside this image or not. So that's the image score, image F1. And the pixel F1 is, given an anomalous image, if the model localizes the anomaly inside the image as well, right? Not just like saying, hey, there's this image, anomalous image, but also show me where the anomaly is. So this is the pixel F1. And we're going to be taking the harmonic mean between image F1 and the pixel F1, and that will be the final score, basically. So this is going to be the main criteria for the first category. But in the second category, we will only use image F1, and mainly because, there's going to be a logical anomaly involved in this one as well. So if the users or the participants utilize text or language, so they may not able to find the exact location, or if maybe their model might just say, hey, the push pin is broken, or the screw is broken, or some parts in the screw is longer than the normal and stuff like that. So it might be a bit difficult to exactly localize the anomaly, but as long as the model predicts that there's something wrong with this image, both logical and the structural perspective, then that's fine. So that is the main reason we just evaluate based on the image level score.
Yes. So for the submission format, so I think that maybe this is the question that some of the participants or attendees in this live have right now. So we are expecting to receive submissions in a zip folder. So we are expecting to receive that in the Hackster web page, in in the submission tab. And basically we are expecting to have a Python module, a Python file, the requirements, the model with the weights, and a README file. So basically we are expecting to repeat the work, and we need to see also the report. The report is also important. So basically we want to use, and this is pretty open, so we could receive a PDF as a report also in the zip file, and also you can put the report embedded in the Hackster page when you have a project description in these kind of things. So, but basically we need to be sure that we can repeat the work to evaluate all the things that you are claiming on the submission, and we need to have this five files: the report in PDF, the Python script, the requirements, the model, and the README file. Anything else, Samet, that I'm missing?
No, that's pretty much it. And we tried our best to write as clear as possible these instructions. But if there is anything that's unclear to you, feel free to reach out to us either on the discussion section of the Hackster or on the Discord. We are more than happy to help you out.
Yes, so give me 1 second. I want
Excellent.
to show right now the Discord channel that we have. This is also, you can access the Discord channel in Hackster as a resources, so you can take a look of we are starting the engagement with all of you here. And anything else, anything that you have in mind, good things, bad things are well received. So I saw a comment that prices, okay, we have prices this year. Last year, the challenge didn't have prices. So, but right now we have prices, and I will let you know what prices we have. Oh,
Yes,
okay.
the prizes are essential.
So, and we were talking about Anomalib, Anomalib. I'm a Anomalib lover. So because, it's solving a lot of things in the computer vision field. And right now we can also utilize Anomalib to evaluate the submissions. So Samet, could you explain us how Anomalib will be, what is the role of Anomalib, the library here in this evaluation?
Sure. The advantage of Anomalib here is that the Anomalib has all this bits and pieces, all the components that a participant might need, all the way from data modules to models or evaluation matrix and so on, or maybe visualization matrix, whatever they need. But we didn't want to force people to use Anomalib, but they are free to use any tool that they want. But for the evaluation, we're going to be using Anomalib data module and Anomalib matrix because we think that it's the easiest tool for us. But yeah, that if they want to kind of have some closer script to ours, we shared a sample script on the Hackster, I think in the submission section already. But yeah, we're going to be utilizing the data module and the matrix from Anomalib basically.
Awesome. That is awesome. And if you are not familiar with Anomaly, just take a look of the repository, and we have, I will say we, because I already made some contributions to the repository. We have some amazing notebooks that you can, follow up, getting started, how we can optimize with OpenVINO as well, and, some use cases with the robot, the famous robot.
Yeah. I saw a question or comment on the chat about the Anomalib documentation, updating the documentation.
Yeah.
Yeah, we basically released V1 quite recently, about a month ago, which kind of introduced some breaking changes here and there. So that required some major updates, including documentation. So the documentation was a complete rewrite. But we're trying to constantly improve the documentation for any parts that you think missing or unclear. Let us know, create an issue, or create a discussion or Q&A, whatever. We're more than happy to update it.
The channel in that case is the repository, no? Just okay. Yeah. I don't want to, maybe we can see some questions about Anomaly in Discord, but it's fine as well. But we can follow up that better in the repository.
Yeah.
Okay, I think that we are almost done for the challenge, and we have prizes. So the grand prize will be the new Intel AI PC, and I think this is an amazing laptop. I already have one with me. So, and that laptop is great because we have CPU, the new CPU that Intel has, that is Ultra Core, and that will be Ultra Core 7. And we will have also integrated GPU that is also running a lot of new AI and boosting the AI with a single GPU. It's not discrete GPU, it's an integrated GPU. And also, we can see also some versions with discrete GPU. And also we will have the NPU, that is the new device, Neural Process Unit, where we can also boost the AI for some specific models. So we will have one grand prize per category. So that means that we will have 2 AI PCs. And also the second place will win the new also Intel discrete GPU, the ARC 770. And that will be also a great boost for the ones that are running inference. I'm an inference maker. You see that?
I see that. You're an inferencer.
I'm inferencer. So the ones that when they want to run the inference with a better throughput and latency at the edge. So we have 2 amazing prizes here, and that is great. So as I mentioned before, last year, unfortunately the workshop didn't have prizes. Right now we have prizes. We have a really good things around the challenge. So before to jump to the next topic, I want to double check time, so we have maybe some minutes more. It's fine if I would extend.
Cool.
Okay.
We can go over. It's all good.
Okay, perfect. As Samet mentioned that before, so we can take some questions. Also through Discord, and you can also connect with us in LinkedIn. You can find my face in LinkedIn. So Paula Ramos. But continuing with the engagement that we will have at CVPR, we have a tutorial. So that full day tutorial, and we are so excited with that tutorial. So basically what we want to show there is the capabilities that we have with all the open source libraries that OpenVINO can provide. So basically we have Anomalib is part of the ecosystem that OpenVINO has. We have also OpenVINO training extensions, but also we have the OpenVINO runtime. So basically what we want to show here is how we can combine all of the open source libraries that we have in our ecosystem to solve problems in the industry as well. So as I mentioned before, we have a full day where we want to cover fundamentals for those libraries that I'm talking about. And we create 3 modules where we want to jump in different kind of interesting topics. The first one is, all the end-to-end pipeline that we can cover with OpenVINO training extensions, from data management, training, fine-tuning, optimization for the computer vision task. So, and also we want to provide hands-on experience with multiple devices, across Intel hardware, but it's also possible to use non-Intel hardware as well. So the module 2 is really interesting. So we want to show generative AI pipelines with stable diffusion and LoRa weights. So basically, we want to show how it's possible to fine-tune models with LoRa weights and also provide hands-on experience. And the module number 3 is related also with generative AI and computer vision. So we are making a mix here of these 2 topics, and for showing the optimization with the NNCF. That is another library that the OpenVINO ecosystem has for quantize and optimize different models. So we are so happy, and we are preparing this. I think that from the end of the last year, and we have a lot of talented people around I mean, it's not just Samet or I. So we have Ria, Alexander, Fiona, Shuo, Yuri, Raymond, and Adrian helping us to prepare this and deliver this as well. And at the end, we have also this amazing idea to have the networking meetup, and we are expecting to have you there and have maybe some drinks, food, and also share with you and learn with the new demos. This is the demos that we show in 2023, but for sure, something that we want to repeat is the funny experience, and enjoy having this networking session with all of you. So I think that is all that I have. I just want to close this. That this is for me personally, computer vision pattern recognition conference is one of the most important conferences in the world. So where we need to combine different experiences, and also I know that we will be more than happy to share with you and enjoy at CVPR. So after this amazing information, you will join us at CVPR. This is a question mark that I want to see in your reactions in the chat. So for me, no doubts, and I would like to see you there.
Absolutely. I will, in fact, be there in Seattle for CVPR this year. I'm really looking forward to this. Last year's event, the networking event, was extremely fun. I think people get very surprised when I tell them that the best party at CVPR was thrown by Intel, but it was true. It was true. You all know how to do it right. If you don't mind, Paula, go ahead and unshare your screen here, and I will do our trivia giveaway. Oh, go ahead.
I just want to share something. We have a worldwide team also that you can, maybe if you're interested to connect with some of our evangelists, that will be great. And also a little announcement that we will have also Intel Innovation in September. So if we want also to attend, there is an amazing conference that Intel is hosting in San Jose Convention Center in California this year, and I will happy to see you there. And please, again, connect with us. And I think that, thank you for this time, Phil, as usual. That was an amazing conversation with all of you. Samet, thank you so much as well.
Thanks for inviting me. Thanks.
Yes, thanks so much to both of you for presenting here today. A lot of exciting information, I think, for the global OpenCV audience, especially folks that will be attending CVPR or maybe going to Intel Innovation. I'll try to stop by Intel Innovation. It's pretty close. I can hop on the train.
Please,
Yeah.
I will wait for you there.
All right. Well, I mean, I said it on the air, so I have to do it now. That's the rule. So yes, now I think is a great time for us to do our giveaway. For those of you that don't know, or if you just need a reminder, one of the things we do on this show is give away something to you in the audience on every single episode. On this episode, we're going to be giving away the one free OpenCV University course. You can see what courses are available by going to opencv.org/university. The way this works is I'm going to ask one trivia question, and the first person to answer in the Zoom chat correctly will win the OpenCV course of their choosing, absolutely free. So get ready to answer in the chat. If you have won in the last couple of months, please don't answer and give someone else a chance to win. I'm talking to you specifically, Partha, our resident trivia shark. So we've talked a lot about various software libraries today, OpenCV, OpenVINO, and Anomalib. These libraries, in addition to being open source, have something very important in common. They all have the same license attached to them. What is that license, and what version is that license? All right, Pamudu, just right, super quick there. You nailed that one. The answer we were looking for there was Apache 2.0. These are all Apache 2 licensed softwares. Pamudu, please send one email to phil@opencv.org with the name of the course you would like, and we'll make sure that you get that thanks to the blazingly fast response times of the OpenCV University support team. I mean, yeah, we went a little over today. I think, the folks, a couple of folks asked, Paula and Samet, where can folks find you online if they want to follow you, if they want to say hi on your various social media platforms or send you an email? What's the best way for them to do that?
I'm on LinkedIn. Just Paula shared in her last slide, I guess, a link, but I can share. I'm happy to share the.
Yeah, so same LinkedIn on my side as well.
Excellent.
So yes, I try to have a meaningful conversation with developers there as well. So you feel free to text me as well, connect with me and text me. I will be happy to have conversations with all of you.
Excellent, excellent. And on next week's show, we've got an exciting announcement from OpenCV partners at Seventh Sense. Please stay tuned for that next Thursday at 9 a.m. It's going to be very exciting. Thanks so much again, Paula and Samet. This was very interesting. I'm really looking forward to see what people accomplish with this new challenge, and who wins that extremely nice high-end Intel laptop.
So Phil, we will have DevCon, it's a developer conference that we will host in with the Intel OpenVINO team in June, just after CVPR. We will share also in that webinar the results of the challenge. So
Excellent.
I will be more than happy to share that with you as well.
Yeah, we will definitely make sure the OpenCV community is primed and ready to see those winners. I'm looking forward to that as well. Thanks so much for joining us, everybody watching out there. We would not do this show if you didn't watch us. We really do appreciate you joining us, spending your Thursday morning with us here. We peaked at about 225 live viewers. I sometimes still cannot believe that many people at once are watching our little show, but thanks so much for your attention, for your questions, for your time, and for your friendship. Paula, Samet, we'll have you back, I'm sure. Everybody out there, take care of yourselves, take care of somebody else if you can, and have a great day wherever you may be.